Good day. Today we are going to implement the logic and operation in a virtual breadboard using TinkerCAD. Let's start. First, let's open tinkercad.com from our web browser. Make sure that you are signed in or you have an account in TinkerCAD, and then go to Circuits. Click Create New Circuit. And then we need to place our components. Let's first place our breadboard. Oh wait. Choose a name for your circuit. Here I wrote logic and function example as the name of my circuit in TinkerCAD. And then I will place the breadboard. I will choose the long breadboard. Then search the AND IC or integrated circuit. This is in the IP package. So the quad AND gate. This is the 74HC08 IC chip. We've placed it in the middle of the breadboard. Then let's search for the specifications of this chip, the pin connections. Let's look at this chip. It has 14 pins and it has 4 AND gates inside the chip. For the first AND gate, the pins are 1, 2, and 3. And then we have the ground connection in pin 7 and power supply in pin 14. VCC pin, which is pin 14. So we will only be using the first AND gate with pin connections 1, 2, 3. Then we'll put the LED. One LED. Our function is the circuit will allow the LED to light up if both of the inputs from the AND gate, which are the slide switches. We will choose the slide switches. If both of the slide switches are on, it will light the LED. Because this is the function of the AND gate, if both of the inputs are high, the output is high. And if either of the inputs is low, the LED will not light up or the output is low. We'll place the resistors. This will be for the connection of the switches to ground. Then we'll search for the power supply for our LED and for our entire circuit. The power supply for our chip and LED. But we need to know the specifications or the power requirements of our IC and our LED. For our chip, let's try to search for the data sheet of this IC. Let's search for the data sheet. this to the right. Search again. I think this is the right one, the quad 2 input AND gate. Quad because there are 4 AND gates inside the chip. What is the input supply voltage requirement of this chip? VCC, the range of VCC is, you notice the pin connections. Supply voltage, VCC, minimum is negative 0.5, maximum is 7 volts. So typical value is from 3 to 6 volts. VDD or VCC is from 3 to 6 volts. So let's choose which one. 9 volts, 3 volts. We will choose 3 volts. Should we place it inside? Let's just place it outside the breadboard. Then connect the positive to the breadboard. Let's choose the upper horizontal connections to be positive, the negative for the lower. Change the color to red for positive. Let's connect first. It's for the negative and then positive. Red and then black for the negative. Red and then black. Next, let's connect the we know that in the middle part of the breadboard they're not connected, so let's connect them. Let's move the slide switch. Let's apply ground or 0 volts to VSS. Pin 7, which is pin 7. 1, 2, 3, 4, 5, 6, 7. Pin counting is counterclockwise. That's ground. Then pin 14 for VDD or VSS. VCC. VDD or VCC. It's connected to the positive of the power supply. Pin 14. Red for positive. So we already connected the supply voltages. Next is for the AND gate. The inputs are pins 1 and 2. Let's connect them to the center of the slide switches. Let's move it. Let's move the IC. Connect the pin 1 of the AND gate to the center of the slide switch. To the center of the slide switch. Wait. Set to center, and then same with pin 2, the second input of the AND gate. Let's first connect the connections for the slide switches. So positive for the other pin and the negative. Let's erase this one. It's connected to the resistor, and then we'll connect it to ground. Maybe I'll just rotate the resistor. So many wires. So many wires. Let's rotate the resistor. Connect. Let's connect it to ground. Change the color to black. Black. So we have already created all the connections for the first slide switch. Connected the signal to pin 1, and then to VCC power supply for the other, and then ground for the other pin of the slide switch. Next is the second slide switch. Let's connect pin 2 of the IC to the middle of the slide switch. Then connect the ground, the other one. Connect to ground. And we're done. We're done. Then lastly is the output, which is pin 3 of the IC chip. It's connected to the LED. To the positive, the anode of the LED. Try to move. I don't know. I'll just go with it. Stick to it. We've made the connections with the inputs of the AND gate. Next is the output to pin 3. The output pin 3, we should connect it to the positive or the anode of the LED. The anode of the LED, and then the negative, let's connect it to the ground. Sometimes we need to put a resistor to limit the current in the LED. Here I did not put a resistor anymore. So connected at the ground. The cathode of the LED is connected to ground. Let's adjust. Since we moved VDD, let's move the IC and we forgot to move the VDD wire. Okay, let's start simulating. The LED turned on because both of the inputs are on. Then if one is 0, the LED would turn off. Off, then on. Excuse. Then write in the notepad. To make it clear the function of the AND gate. Okay, then for the AND gate, we have X and Y as our inputs, and Z is the output. Let's recall the truth table. 0, 0. If both of the inputs are 0, then if one is high or one is high or both is high, so if both are 0, the output is 0. Then if one is 0, still the output is 0. It will only be high if both inputs are 1. Let's check the first condition where both inputs are 0. So let's put 0, 0. The output is 0. So the LED did not light up. Then 0, 1. The output 0, 1. The output is still 0. The LED still did not light up. 0 for the first and then 1 for the other. Notice the slide switch indicator. Then if X is 1 and the other is 0, still the output is 0, so LED is still turned off. If both of the inputs are 1, 1, that's the time that the LED will light up. So the LED is turned on. That's it. That's for our simple implementation of the AND gate function using a virtual breadboard in TinkerCAD. Thank you for watching. Please subscribe.